Okay, I wanted to go over this one because I think it ends up with some special issues with it. If you look, you have the side splitter theorem going on. So what the side splitter theorem says is that I can do this. I can say x plus 2 over x maybe is equal to 25 over 20. Actually, this one's not as difficult as I thought it was. Okay, so when I go through this, I just say cross multiply, right? We would have 25x, and on the other side we'd have 20 times x plus 2. We have to remember to put x plus 2 in parentheses as a group. So we have 25x is equal to 20x, and then 20 times 2 is 40. So I want to solve for x, and remember when I solve I do PEMDAS backwards. So I'm going to start by, to get x by itself, I'm going to subtract 40 from both sides. So now I have, wait a second, that's not what I want to do. I actually want to get my x's on one side first. So let me go ahead and subtract 20x from both sides. And that way I get all my x's together. 25x minus 20x is 5x. And then the 20x's would cancel out on that side, and I'd end up with 40. And then if I divide both sides by 5, I get x equal 8 for that one. Okay, so let's look at this one. Now this one's a little tricky. You got to pay attention. You've got these parallel lines right here. So if you think about it, if I'm trying to match up what parts of these triangles go together, you might be tempted to think that 6 matches up with x, but it doesn't. Here's what we have to do. We have to say I have parallel lines cut by a transversal. So this angle right here and this angle right here would be congruent by alternate interior angles. Alternate interior angles are congruent. So actually what happens is that you have to basically flip this triangle or twist it and then flip it over. So maybe I'll put twist and flip is the way this thing matches up. So if you start with your x, for instance, x is actually going to match up with 4 on that upper triangle. And since I put x on the top on my ratio, I'll put another side on this bottom triangle, 10.5. It actually matches up with 6. So you got to be careful about how you match these up. Some of the other ones don't do this. For instance, number 4 on this page does not do that. It matches up just basically folded over. But I have to twist this before I fold it over. Okay? So now if I cross multiply, I get 4 times 10.5, which that's 42. And then I get 6x. So 6x is 42. If I want to get x by itself, I could divide both sides by 6, and I'd get x equals 7. So that's what we would do on this one. Okay, this triangle really shows us the importance of going ahead and drawing the two triangles separately. So what I'm going to do is I'm going to come over here and I'm going to split this into the two triangles, because remember we can't, well actually I don't have to, now that I think about it, I don't really have to do that here because I've got these parallel sides. So couldn't I use the side splitter theorem here? The side splitter theorem says that I could take x plus 2 and put it over 9. Now if I think about x plus 2, what does it match up with on the other side? It matches up with, on the other side, just that bottom piece. It's like this piece matches up with this piece. And then on the 9 part, the 9 that I have here would match up with whatever this side is. Well, this side is not 14 and it's not x. As a matter of fact, how I have to think about that is it would be 14, but I got to take the x out. So it would be 14 minus x. So this is going to present us with a problem that may be a little more difficult to solve than we first think. So let's give it a shot and see what happens. When I cross multiply, I get 9x equal, oh my goodness, I get x plus 2 times 14 minus x. So let's multiply this out and see what we get. X times 14 is 14x. X times negative x is a minus x squared. 2 times 14 is 28, and 2 times negative x is negative 2x. Okay, so if I combine like terms, I'm going to have, actually let me put the negative x squared first. I have 14x minus 2x would be 12x. So those terms would combine, and then I have a plus 28. Now I have a negative x squared, and I'd really like it to be positive. So let me do this. Let me add x squared to the other side. I have to get all my terms together because this is a quadratic equation. A quadratic equation has a square in it. And if I'm going to solve it, I'm either going to have to factor it or use the quadratic formula. And I am hoping for factoring because I don't like the quadratic formula. So I have x squared plus 9x. Now let me move the 12x over. I'll subtract 12x from both sides. So it'll be minus 12x. And the last thing I need to do is to subtract the 28 from both sides. I'm running out of room, so I'll just write it over here. So now everything's on one side, and it's equal to 0 because everything is canceled out on the right-hand side. Remember that when I'm solving quadratic equations, whether I factor them or use the quadratic formula, I still have to get 0 on that side. Okay, so let's see what happens. X squared, 9x minus 12x is minus 3x. Minus 28 is equal to 0. I think this factors, thankfully, because to get x squared, I put an x here and an x here. If you think about it, if you remember the little device we used last year to kind of help us if we were stuck, I'm trying to find two numbers that multiply to give me the number on the end, negative 28, and at the same time, those two numbers had to add up to negative 3. Okay, well, I know that 7 times 4 is 28, and there's a difference of 3 here. If I made it negative 7 plus 4, it would give me negative 3, and negative 7 times 4 would give me negative 28. Those are my missing numbers. I'm going to put minus 7 on one factor and plus 4 on the other. Now, if you remember how I solved for x here, if I have two things that multiply together and they give me 0, I know that one of the two things has to be equal to 0. And it could be either one of them. So let me try them out. X minus 7 equals 0. I could solve that one by adding 7 to both sides. And I could get x equals 7. That's a good solution. Now I've got another factor though. It's x plus 4 equals 0. If I subtract 4 from each side, I get x equal negative 4. I first think, oh, there's my other answer. I got two answers here. But the problem is, can I have a segment that is negative 4 long? No, we always use positive numbers to talk about that. So this answer right here is actually just kind of garbage answer. Sometimes that happens. So my answer to 14 is x equals 7. All right, here's number 8. And if I look at number 8 and how I need to think about it, I notice that I've got this angle here is equal to this angle here. So this would be one of those that's going to be that angle bisector similarity theorem that we talked about in class, and I actually wrote something about it on Course Sites if you need to look at that. And what that theorem says is that I can take that's the line right here that bisects it. It cuts this line that I'm going to outline in green into parts that are proportional with the sides of the triangle. Here's the problem. This little piece is x, but what do I call this piece right here that I'm going to put a dot on? Well, it's not 15 and it's not x. As a matter of fact, the whole thing is 15, but if I want to know how long that piece is, I have to take x out, don't I? I have to subtract it. So if I start thinking about how to set my proportion up, I would say, well, x might go to 10 the way that 15 minus x goes with 15, okay? So that's actually not going to be too bad to solve. I just have to be careful because that piece right there, it's not 15 and it's not x, so I can't just describe it with one of those two words. All right, so let's cross multiply. I have 10 times 15 minus x. I'm going to put it in parentheses just so I don't forget that I got to distribute. And on the other side, I have 15x. So now I got to distribute on the left-hand side. 10 times 15 is 150, and 10 times negative x is negative 10x, or minus 10x. That's equal to 15x. Now when I'm solving these equations, I have to get all my x's on one side. I can't just, I can't really start solving this till I get them together. I have more x's on the right, so I'm going to take these 10x's here, and I'm going to add them to the other side to put them all together. Because remember, I can add and subtract terms just to move them from side to side. That would leave me with 150 on the left, and 15x plus 10x is 25x. And now I'm just trying to solve for x. So if I want to get x by itself, I could divide 25 out of it, because that would cancel out and leave me with just x. 150 divided by 25 is actually 6. Let's see. Yep, 6. So x equals 6 is what we need to do for 8.